Hey makers, welcome back to Code and Current Studio. Before we dive into more blinking lights and rotating motors, let's take a moment to meet the real star of the show, the Arduino Uno. Think of it like this: if your project were a band, the Arduino would be the conductor, the composer, and the sound engineer all in one. It listens to the world through sensors, makes decisions with your code, then acts, lights up LEDs, spinning motors, or sends signals to other devices. But to really unlock its potential, you'll need to know your board like the back of your hand. So today we're going to go on a guided tour of the Arduino Uno, pin by pin, part by part. By the end of this video, you'll not only know what each component does, but you'll also know how and when to use it on your own creations. Let's get started. The microcontroller. At the center of the board is the microcontroller. This is the brains of the Arduino. It stores and runs the code. Along the right edge of the board, you'll see 14 digital pins. These are used for digital read, digital write, and analog write, though analog write only works on the pins marked with the PWM symbol, or the pulse width modulation symbol, the little wave. Pins 3, 5, 6, 9, 10, and 11 support PWM output, which lets you simulate analog symbols. Pins 0 and 1 are used for serial communication, receiving and transmitting data. Pins 2 and 3 can be used for external interrupts, which lets your code react instantly to changes. The AREF, this is an analog reference pin, used if you want to change your reference voltage for analog readings. Built-in LEDs. There are a few LEDs built into the board. The L LED on pin 13 is the only built-in actuator. It's perfect for your first blink sketch and great for debugging. The TX and RX LEDs blink when the data is being sent or received between your Arduino board and your computer. Expect them to flicker during uploads or serial communication. The power LED lights up when your board is receiving power, another useful debugging tool. Analog pins A0 to A5. On the other side of the board, we have 6 analog pins labeled A0 to A5. These are used for analog read to read values from analog sensors like temperature or light sensors. They're converted the signals into numbers between 0 and 1023 using a 10-bit ADC. Tip: these analog pins can also be used as digital pins. A0 becomes digital pin 14, A1 becomes digital pin 15, and so on. Power pins. Let's talk about power. The Arduino has several power pins. Then, this is where you can supply voltage from an external source, like a battery. It accepts 7 to 12 volts. 5V. This is a regulated 5-volt output that powers the board. 3.3V. Some components need 3.3 volts instead of 5. Ground. You would use these pins for your ground connections. Other key components. USB port. This port's used to power your Arduino, upload your sketches, and communicate with your code using functions like serial print. Reset button. Press this to restart your program. It resets the microcontroller. Voltage regulator. The voltage regulator ensures the board gets a stable 5 volts. Crystal oscillator. This component keeps time for your microcontroller. This one runs at 16 megahertz. Power connector. This is how you power your Arduino when it is not connected to the USB. It accepts voltages between 7 and 12 volts. And that's your guided tour of the Arduino Uno. Now that you know what each part does, you're ready to build smarter, troubleshoot faster, and create with confidence. If you found this helpful, make sure to hit that subscribe button and turn on notifications, because here at Code and Current Studio, we're just getting started. I'll be walking you through hands-on projects every week, from blinking LEDs to build your full-on smart devices. And if you're ready to start building, check out the Arduino kits and accessories linked in the description. I've curated a list of beginner-friendly products that I personally recommend, perfect for following along with these tutorials. Every purchase helps this channel and keeps the content coming. Thanks for watching. We'll see you for the next project.